You're crouched by a fire 200,000 years ago, turning a stone flake over in your hands. You've already tied it to a wooden shaft with sinew. Twice. Twice it slipped loose mid-hunt, and both times you watched an animal run off carrying your only working point with it. Right now, if something breaks, you reach for a tube of glue you bought for a few dollars and forget about it 30 seconds later. You don't think about the chemistry holding your phone case together, or the adhesive under a Band-Aid. No mixing, no guessing, no waiting by a fire to see if today's batch actually works. Glue is invisible technology. It only stops being invisible when it's the one thing standing between you and going hungry. So how did people with no chemistry, no lab, and no written language figure out how to make something stick permanently, reliably, on purpose, tens of thousands of years before anyone wrote the word adhesive down? In 2006, geologist Paul Peter Mazza and his team examined 2 flint flakes recovered from a quarry at Campitello, in Italy. Both were coated in a black residue. Chemical testing identified it as birch bark tar, deliberately manufactured, not naturally sticky like tree resin. The flakes date back roughly 200,000 years, making this the oldest known adhesive ever produced by a human species, likely Neanderthals, long before Homo sapiens looked anything like us. Birch bark doesn't ooze glue on its own. You have to burn it exactly right. Hot enough to release the tar, not so hot you burn it to nothing, inside a narrow window of roughly 250 to 400 degrees Celsius. Miss that window, and you're left holding ash. So if that's the earliest evidence, what came next? Fast forward about 130,000 years. In 2009, archaeologist Lynn Wadley, working with a team from the University of the Witwatersrand, published findings from Sibudu Cave in South Africa. Her team found stone points dating to roughly 70,000 years ago, coated in a compound glue built from several ingredients at once: plant gum, red ochre, sometimes a trace of fat or beeswax, mixed in specific proportions and heat-treated over a low fire. Wadley's team rebuilt the recipe by hand to test it. Too much heat and the glue turned brittle. Too little and it stayed soft and useless. The margin for error was narrow enough that Wadley argued this level of planning, juggling several ingredients, timing, and temperature, simultaneously required something close to modern working memory. Everyone assumes red ochre at a prehistoric site means body paint, or ritual, a shorthand for early humans getting spiritual. At Sibudu, the ochre wasn't decoration. It was an engineering ingredient, the exact compound that kept the glue from turning gummy in the heat. In Germany, at a site called Königsaue, excavators pulled 2 lumps of birch tar out of the ground back in 1963. They're dated to somewhere between roughly 45,000 and 80,000 years old. One of them still holds something startling: a partial fingerprint, pressed into the tar while it was still soft. Not a tool mark. An actual print from an actual hand, almost certainly Neanderthal, caught mid-task and frozen there for tens of thousands of years. Here's where the story gets complicated. In 2019, researcher Patrick Schmidt and colleagues published a paper in PNAS arguing that birch tar could be made by pure accident, just by burning bark near a rock or letting it smolder in embers. No real skill required. Then in 2023, a separate team led by Tabea Koch chemically re-examined the actual Königsaue tar and compared it against dozens of experimental samples made with different Stone Age techniques. Their conclusion: those 2 specific lumps weren't made the easy way. Their chemistry matched an underground, low-oxygen method bark packed into a pit or a covered structure, distilled out of sight, with no visible flame to watch and copy. That's a process you'd have to be taught, or invent once and then remember. So which is it? Accident or invention? Probably both. Simple tar smearing was likely stumbled into more than once, by more than one group. But the Königsaue pieces suggest that somewhere along the way, someone turned a lucky accident into a repeatable, teachable method, and that leap from stumbling into stickiness to engineering it on purpose might be the real discovery here. But does any of this actually hold up as real engineering, or is it just a nice story archaeologists tell? In 2016, materials scientists Paul Kozawik, Gieske Langejans, and Johan Poulis, working out of the Adhesion Institute at Delft University of Technology in the Netherlands, decided to find out. They mixed up batches of Stone Age glue recipes, plant resin, beeswax, ochre, in different ratios, and ran them through the same lap shear and impact tests used to certify modern industrial adhesives. The compound recipes, the ones combining several ingredients, consistently outperformed the single-ingredient versions under stress. These weren't campfire guesses that happened to work once. They were, by modern engineering standards, genuinely better-performing formulas, arrived at without a single instrument more advanced than fire and patience. For a long time, the story of the Stone Age has been told through spearheads and hand axes, the sharp stuff, the dramatic stuff, the stuff that photographs well in a museum case. But a stone point with nothing to hold it to a shaft is just a rock. The actual weapon, the thing that let a slow, soft-toothed primate bring down animals 10 times its size, was never really the stone. It was the bond. Think about what that bond actually demanded. Someone had to notice that heated bark behaves differently than raw bark. Someone had to test ratios of gum to ochre to fat, fail, adjust, and try again, probably across many failed spears and many missed meals. None of that gets preserved as a fossil. There's no skeleton of patience. There's no skull shape for willingness to fail 9 times before getting it right. The only trace it leaves behind is a smear of chemistry on a 70,000-year-old flake, which is exactly why it took modern chemistry to even notice it was there. Glue is what turned a pile of separate objects, a rock, a stick, a strip of sinew, into one reliable tool you could trust with your life. It doesn't cut anything. It doesn't look like much in a display case, and it might be one of the clearest signs we have that, deep in an unrecorded past, someone sat by a fire and thought several steps ahead. Picture that same hunter again, crouched by the fire, turning the flake over one more time. This time the point holds. The tar has cured hard, the fibers underneath still flexible enough not to snap. They don't know they've done anything remarkable, they just know the spear works now. You'll never crouch by a fire wondering if your tools will fail you tomorrow. You'll never test a compound by hand for weeks until the proportions are right, because somebody else already did that 70,000 years ago, in the dark, with nothing but trial, error, and fire. Every object in your life that's held together and stays held together is standing on top of that patience. We didn't invent the desire to make things stick. We just forgot how hard it once was to learn. You're crouched by a fire 200,000 years ago, and your spear point keeps slipping loose mid-hunt. There's no such thing as glue, yet not the way you know it. Someone has to invent it first, ingredient by ingredient, failure by failure. This video traces the real archaeological record of how ancient humans and Neanderthals engineered the first adhesives, from a quarry in Italy, to a cave in South Africa, to a lignite pit in Germany.